In this video, we're back to using the summation formulas from the previous examples. Now you'll notice I'm going to start at I equals 1 and I'm going to go up to 20. I'm going to have 4 plus 3i. Now, if I look at this very carefully, the fact that I start at 1, I end at 20. That means I can technically visualize that I'm ending at some n value, and I can treat this just like I treated all the summations in the previous assignment. So, this is going to be the summation of I equals 1 to 20 of 4 plus the summation of I equals 1 to 20 of 3i. Now I can separate this because the separation of addition or subtraction isn't going to change the variables or the values. I can then also take this summation right here and pull the 3 out of the summation because it is a constant multiplied by a indexing variable. So you'll notice that this is really what I have. Now I want you guys to see this. I want you guys to utilize it. I do not need you guys to write it on all of your homeworks and on most of your tests. I need you to truly understand how these summation variables are allowed to work and not allowed to behave. So now in this case right here, because I'm starting at 1 and I'm going to 20, and all of my formulas start at 1 and go to n, that means I can treat this 4 as though it's a constant. That means it's the first example right here. And the constant in the summation is equal to the constant times n. N being the end of that summation. So this piece right here is equivalent to c, which is 4, times 20, which is n. And therefore I'm going to have 80 for that first summation value. On the second piece, this one right here, I'm going to go ahead and use the value for I in the summation. So now it's going to be 3, I'm going to write that down, that's the 3 that's outside, multiplied by the summation of I equals 1 to 20 of I. Keep in mind, n is 20, so that means that I'm going to be equal to this thing right here, where n is 20. So it's going to give me 20 times 20 plus 1, which is 21, all divided by 2. This provides me with a very large number, definitely, clearly. I'm going to go ahead and simplify this as easily as possible. So what I'm going to do with this is I'm going to go ahead and cancel out the 20 and the 2 and give me 10. So it's 30 times 21. The next thing I'm going to do is I'm going to note that these two things are actually added together. It's 80, this summation, plus 30 times 21, this summation. When I take these two, I can actually factor out a 10. A 10 from the 80 giving me 8. And I can factor out a 10 from the 30, giving me 3. This allows me to do some nice simple mental math. Now again, a lot of this work you can do in a calculator, but I'm doing this by hand and with numerical manipulative math to make it so that you guys can see this. I'll do 3 times 21, which I can do very easily, is 63. 63 plus 8 is nothing more than 71. And then 71 times 10 is nothing more than 710. And that is what that summation is equivalent to. In the next example, we're going to work with summations that are not actually starting at 1. So now there's a couple of different things we can do with this. We can first utilize this to the best of our ability without transitioning it to 1. However, that means we won't be able to use the formulas in the previous formula page. So what I'm going to do instead is I'm actually going to take this, and instead of starting it at 3, I'm going to subtract 2 from that bound, which means I have to subtract 2 from that bound as well. By subtracting 2 from both those bounds, it changes the summation to start at 1 and end at 13. Now, what I also have to do is if I subtract 2 from the outside, I have to add 1 to this I value on the inside, which means that this I right here is now changing to I plus 2. And then this 1 I still have to add in, which means that my summation is now I plus 3. Now, if you don't trust this, again, by all means, check it. If I plug in 3 to this right here, I get 3 plus 1, which is 4. My first term should be 4. If I plug in 1 here, I get 1 plus 3 is 4. I still get 4. If I plug in 4 for my next term, I get 5. If I plug in 2 for my next term, I get 5. If I plug in 13 for my last term, I get 16. If I plug in 15 for my last term, I get 16. These two summations are actually the same thing. But by seeing them this way, I can now identify that these are two separate summations. And again, this will probably be the last time that I write it this way. But this is the way that you really need to be able to visualize them. Because this is nothing more than a constant, 3, times 1 to 13, n being 13. And this one down here is nothing more than the exact same case of n times n plus 1 all divided by 2. It's that I case. So that's plus, I'm going to have my n is 13, and then 13 plus 1, which is 14, all divided by 2. Now I'm going to verify that formula because, again, I don't have it memorized off the top of my head, but you'll notice n times n plus 1 divided by 2. N, in this case, is 13. So 13 times 14 divided by 2. Now, again, we can try and multiply this stuff out, but I'm going to get lazy. There's a 13 here. There's a 13 here. Let me factor out a 13 and get 14 over 2, which is 7, plus 3. Well, that's real easy. That's 13 times, again, 14 over 2 is 7. 7 plus 3 is 10. So it's 13 times 10, which is 130. Again, we can do all of this math without any calculator.